So in the previous class we have seen how classless address mechanism will overcome the problem of the classful IP addressing mechanism. So in this class we are going to discuss the classless addressing mechanism. So for that we are using the subnetting concept. So why we require the subnetting concept means first we will understand. So subnetworks or subnet is a logical subdivision of the IP networks, right? Subnetting is process of the dividing the single network into the multiple smaller networks. So why we need to perform the subnet mask means it help us to minimizing the wastage of the IP address. Now what is the meaning of this one is, suppose for example as we discussed in the previous time, so suppose I am going to take some any class IP address. For example, let me take the class C IP address, right? So the IP address is something like this: 192.168.1. some value IP address. Now if you observe here, class C means network portion, host portion, right? So in the host portion is nothing but the 8-bit representation. These are all the 8-bit representation. So always network portion will be constant. In host portion 8-bit only we will be getting the 256 IP addresses. Now see that as per my, this is my something network, I have purchased one class C network. So by default I am getting the something called as the 256 IP address. But my requirement is that in my organization I have only 3 computers. So I can able to give 3 unique IP address for this 1, 2, 3. Out of 256 I am going to use only 3, remaining 253 are wasted. Reason is that the single network it is giving the 256 IP address. As we have only 4 billions, right? So very less number of the IP addresses. Again we are wasting the maximum number of the IP addresses, right? Now to overcome this problem of the classful concept, what we are going to do is, so here if it is single network means we are wasting this many IP address, right? Now the question is that if I can able to subdivide this one network into the multiple number of smaller networks. Suppose for example I have divided this network into the something around 10 different networks, right? So each network I will be having the 20 IP addresses, something like this. Now see that here one network, right? So how many IP address here we will be having? 20 IP address. How many here we are using? 3. How many wastage is there? Out of 20 we have the 3 we are using, 17 is wastage. Now see that earlier case what is happening? We are getting 256, we are using only 3, so 253 are wasted. So like this, after performing the subnetting concept, we can overcome the problem of the wastage of the classful IP addressing mechanism, right? So for that reason we are going to divide the one network into the multiple smaller networks. That is what we called as the subnetting concept. If you see that, so in class C network something, we have the network host portion, right? So 8-bit means we will be getting the 256 IP address. If you are using, if you are not using, this will be remain to you only. Now what I am going to do is make the efficient operation means this piece I am going to cut into the 4 parts. Each part I am going to assigning something called as the 64, 64, 64, 64. This will be assigned to the some company. This will be assigned to the some company, some company, some company, right? So earlier we have only one network. Now this turned up into the 4 networks so that we can able to assign the IP address mechanism very proper manner, right? So one more point to be remember is that subnetting we can implement in terms of the 2 classification, 2 approaches. Remember that there is no use of the classful addressing like class ABCs, right? So classless mechanism we are using the CIDR concept. As we told that CIDR we are representing with the slash notation, right? So we have the 2 types of subnetting concept. One is called as the fixed length subnet masking, another one is called as the variable length subnet masking. So we will see that first what is the difference between the FLSM versus the VLSM, right? So see that FLSM creates subnets of the same size, but VLSM creates the subnet with the varying size. Subnet means dividing the one network into the multiple networks according to our requirement, so that we can stop the wastage of the maximum IP addresses. Now if something is the same size, then it is called as the fixed size length subnet masking. Depends upon our requirement. If you are going to divide, then it is called as the variable length subnet masking. Now we'll see, for example I have the cake something like this. So by default how many IP address I am getting 256. As per my requirement, I cannot able to eat the entire cake, nothing but something 2 kg cake. Now what I have divided, I can eat only something around the small pieces. So I have divided into the multiple pieces. See that earlier I cannot able to eat the 2 kg cake. Now I can eat the only this part of the cake piece. Then remaining will be given to the some other people. So that we are using the efficient way of the IP address. This is what we called as the subnetting concept. Now what is the meaning of fixed length means? Suppose for example here we have the cake something. Now what we are going to do means, if you are going to cut this cake, each cake should consist of the equal part. Then only this is called as the fixed length subnet masking. But for example, see, let it be this case, I have this cake I have divided into the 4 pieces. Let it be 1, 2, 3, 4 person can able to eat these 4 pieces of the cake. Now something, see that here everything will be fixed side. Now for example, assumption that this is the person who is having this cake piece, he cannot able to eat the entire cake, but he can able to eat only half of the particular given piece. Now see that this piece, right? So this is complete piece, this is piece. This guy cannot able to eat the entire thing, right? So like this guy, he can able to find out one more guy. So but those two people can share this one, so that it will be again become into the 2 parts. So but this is not possible in case of the fixed length subnet masking, right? So now try to identify. Suppose this is the network 256. I have divided into the something like this, right? So one is something, let me draw here so that you will be understanding. I have something like this. Earlier it is something 256. Now we need to identify what is the, which is belonging to the fixed length subnet masking, which is belonging to the variable length subnet masking, right? So for 256 I have divided into the 64, 64, 64, 64, right? So here I have divided something into the 128, 64, 32, 32, right? Now you tell me, this is classful address, right? This is what we called as the classless IP addressing mechanism, right? Now we have the 2 types, right? One is fixed length subnet masking, another one is the variable length subnet masking, right? Now this is the second diagram, right? So which is related to first one or second one? Try to guess the answer. See, in fixed length subnet mask means each subnet should consist of the, or each subdivided network should consist of the equal size, right? But what is the limitation of this one is that here for example, how many we are assigning something around the 64, right? But let it be here only 32 systems are there. Now what we can do, we can divide this portion into the 2 portion, right? 132 will be assigned to the this company, remaining 32 we can assign to the some other company, right? But in fixed length subnet masking, the size of the each side subnet should be same. So here also we will be having the something called as the wastage only. For that they have invented something called as the variable length subnet masking. So out of 256 addresses, if 120 is required, you make it as this one network. In next company they required only 32, make it as 32. In some other company they required something called as only 32, make it as 32. In some company they required something 64, you make it as the 64, right? So here also we have the limitation is that even though 32 is there, but as per the constant we are making as the 64. This is the limitation. This can be solved by what? Variable length subnet masking. Right? Now we'll take some question based on the fixed length subnet masking so that you will understand. But one point to be remember here is that the moment if you are going to find out the FLSM or VLSM type of questions, we need to identify first these things, right? For each subdivision of the network, we need to identify what is the network ID, broadcasting ID, what is the first usable IP address in the network range, what is the last usable address in the network range, right? So subnet mask, which is used to differentiate between as well as the network and host, that we know already, subnet mask. So these things we need to understand, then only we can able to solve the problem based on the fixed length or variable length subnet masking, right? So first we will see what is the meaning of all these things, right? Suppose for example, if you observe here, right? So this is something IP address. So let me take again same class A IP address 192.168.1. something network, right? So these three portion we called as the network portion. This 8-bit we called as the host portion. It means that host portion means 8-bit we will be getting the 2 power 8 is nothing but the 256 IP address. Binary number start from the 0, ended with what? 255. So see that this is the network portion which remain unchanged value, right? So at the host portion, how many IP address we are getting? 8-bit value means 0, 1, 2, 3, 4, 5, 6, 7, 8, 253, 254, 255, right? So this first address, whatever the starting address of this address, we called as the network address, right? Why do we require the network address? You can ask me. Suppose see that this is one different network, right? This is another different network, right? Suppose for example, let's say this network is something 1 dot series, right? This is the host portion we will be getting 0 to 255. Let it be this network is something 192.168.2. See, this is the one network, this is the two network. It means that this is different network, this is different network. Again here also we will be getting the host from 0 to 255. Now see that here also we will be having the 0 to 255, 0 to 255, but this is the different network, this is also different network. Why different network means here 192.168.1 is different value, 192.168 same, okay, but here 2 is the different value compared to the 1, so this is called as the different network. But even though these are the different network, the number of hosts is nothing but here also 0 to 255, here also 0 to 255. Now question the moment if I are going to communicate one device to the another device, suppose I gave something address is something 1.1 or something value. Now how to identify which network it is? Either it is belonging to the 1 dot series or 2 dot series, something like that, right? So for that we require something called as the network addressing mechanism, right? So network address mechanism is the mandatory. The starting IP address of the series is called as the network address, right? So then what is the first usable IP address means after network address, the first IP address we called as the 1.1. This is the first usable IP address. Now what is the last usable IP address means not 255, remember this last IP address we called as the broadcasting address. Now how to remember? The start of the address is network address, the last of the address is nothing but the broadcasting address. Why do we require the broadcasting address? Right? Suppose for example, as I have explained previously, if you have the class A or class B or class C, this is used for only one-to-one communication, nothing but to perform the unicast operation. But suppose the moment first time you are sending the information from this machine to this machine, the packet will go via switch, then switch does not know where the destination device is located. Now what switch will do is something, it will perform the broadcasting operation, right? It will send the packet to the all other interface, right? This is just for example only, not real, right? Now what will be happen means if you want to send some information throughout of the network, then we call something called as the broadcasting operation, right? So which IP address is used to perform the broadcasting operation means the last IP address of the network is to performing the broadcasting operation. Now what is the first usable IP address means the network address, broadcasting address, in between whichever the IP address we will be having, those are the usable IP address. Usable means this we can assign to the end devices or host or computer. So what is the first usable IP address here? 1.1 is the first usable IP address. What is the last usable IP address? 1.254. It means that if you are getting 256 IP address also, out of this one we cannot use two address. One is called as the network address, starting bit value, another one is the 1.255, right? So only usable IP address are the 254. If you still have the doubt, let me take some scenario. Now see that I am going to give some IP address here. Let me erase this one. What is the IP address I am giving? 192.168.1.0. right? Now see that invalid IP for the subnet mask entered. So what is the meaning of this one is, right? So if you observe here as per our discussion, right? So this is our discussion, right? So 1.0 cannot be useful IP address. It means for end devices you cannot able to assign the 1.0, right? So see that if I am trying to give the 192.168.1.1, it is happily taking. 1.2 also it is happily taking, 1.100 also it is happily taking, right? But the moment if you are giving something 0, it is not going to accept, right? So this is used to identify the network. So for that, this 1.0 first usable IP address we are not going to use, right? So again, for broadcasting we are using the last IP address. Now what is the usable IP address? From 1.1 to the 1.254. In class C means total 256 minus 2 is nothing but the 254 are the usable IP address. Now after understanding this one, FLSM concept, VLSM concept, how to identify the network address, broadcast address, what are the useful IP address, now we are ready to perform the subnetting operation. Means dividing the one smaller network into the multiple pieces so that we can able to utilize the effective utilization of the IP addressing mechanism. That is what we called as the subnetting concept in computer networking, which works based on the classless address mechanism of the CIDR operation, right? So in the next class we will consider some problems based on the fixed length subnet masking, so we will solve, right? So now question is something like that: design a subnet that each network or subnet has the 50 number of the host. It means that I have something called as the 50 systems. Each system I need to assign the something. I have 50 system. For each 50 system I need to assign the IP address. Which address mechanism they are asking to use? Class C addressing mechanism. Like they are giving something and perform the subnetting operation. Which subnetting operation? Not fixed length subnetting, not the variable length subnetting masking. For example, they have given use this network mechanism. Use this series. You find out how many subnets we will be getting. After finding the number of smaller networks, for each network you identified the what is the network address, broadcast address, first usable, last usable, subnet mask we need to find out, right? So that we will see in the next class. Thank you.